Hi, my name is Ramiro, and I would like to talk about my research project called Fast Simulation Assisted Shape Correction After Machine. This project is done inside of the AdMoRe ITN with the collaboration of the École Centrale de Nantes, Technical University of Catalonia, and Airbus. Let's start with the problem description. Aluminum forgings are widely used in the aeronautical industry because they are able to produce complex geometries in an economical way. An example of these parts is the cruciform beam depicted in red, which is located in the wing box. However, aluminum forgings present important distortions after machining. This problem is caused by the presence of residual stresses that are developed along the manufacturing chain. Then, when the part is machined, there is a redistribution of residual stresses at an internal level and distortion appears. However, before proceeding to the assembly stage, these geometrical defects must be removed by including an extra step called reshaping. There are 4 mechanical techniques used to remove distortion, and when they are applied, new residual stresses are introduced to the part. At the moment, the current solution is based on the experience of a group of well-trained operators. They are able to detect any distortion, and based on their skills, they know which operation and sequence to use in order to fix the part. However, this procedure is difficult because every part is unique due to its distortion, and fixing them in a tailor-made manner is time-consuming. Then, we would like to know how to optimize the reshaping process. At Airbus, we recognize that the operators are the key factor to fix a distorted part, so we will always need their know-how. During this project, we want to explore the benefits of using numerical simulation tools, especially model order reduction techniques, to study reshaping. The idea is to combine both methodologies with the aim to work as a team, where the final goal is to reduce the total number of reshaping operations to fix a structural part, limiting the amount of extra residual stresses introduced during the process. But why model order reduction? To study reshaping, adaptive modeling is required. Imagine the opposite case. If we work with static data and my experimental distortion is different from the numerical result, any future calculation will be wrong. To solve this issue, we need to launch a parametric study. Doing this efficiently with traditional techniques is not feasible. Then, once we have generated our results, we need to explore the solution in real time. This is a key requirement for any industrial environment. But as you have already noticed, we are dealing with a problem in a high-dimensional space. Therefore, model order reduction is the key to overcome the curse of dimensionality. To sum up, we want to develop a numerical tool to study reshaping. In that way, we will contribute to the big family that makes possible to travel across the skies. This project is funded by the European Union through the Marie Curie Action Program. If you want to know more about the different projects in AdMoRe, feel free to visit our webpage or follow us